Hi students, this is Ms. Johnson with 10-2 Simplifying Radical Expressions, Day 2. Today we are going to continue to simplify expressions with radicals and square roots, but we're also going to do expressions that contain variables. Alright, so let's start off with example 1. We have the square roots, and the square root should go all the way across. Square root of 45, a to the 4th, b to the 5th, c to the 6th. Again, we want to break things down into perfect squares as much as possible. So I know the square root of 45. Let's see. 45, that can be broken down into 9 times 5. Now, variables. When they have even exponents, they can be perfect squares. When they have odd exponents, they are not perfect squares. So, even exponents is what we want. Alright, so a to the 4th, we're going to leave it as a to the 4th. B to the 5th, we are going to break that down into b to the 4th times b to the 1st. Okay? Remember, you add exponents as you are multiplying them, so 4 plus 1 would give us our 5. C to the 6th is even, so we're going to leave that. Alright, then we're going to go piece by piece doing square roots. Well, I know square root of 9 is 3. Square root of 5, that has to stay square root of 5. Square root of a to the 4th. I should put my multiplication signs in here. Sorry. A to the 4th is going to be, the square root of a to the 4th is a squared. A squared times a squared is a to the 4th. B to the 4th. Square root of that is b squared. B to the 1st, that has to stay. That doesn't have a perfect square, so that's going to stay square root of b. And c to the 6th, that's going to be c. Square root of that is c to the 3rd power. Okay, then what we're going to do is we're going to look at everything that is not under a square root sign, and we're going to bring that all out front of the radical. So we're going to have 3a squared, b squared, c to the 3rd power. Then we're going to go back and put everything that's under the square root under the square root. So it's going to be square root of 5b. So if we simplify square root of 45, a to the 4th, b to the 5th, c to the 6th, we get 3a squared, b squared, c to the 3rd times square root of 5b. So there is our answer. All right, let's do another one like this, just to make sure that we understand. Okay, this time we're going to have square root of 72, x to the 3rd, y to the 4th, z to the 5th. Okay, again, let's break it down into perfect squares, and perfect squares are even number exponents. So 72, let's see, we can break that down into 9 times 8. X to the 3rd, we want to have that be x squared times x to the 1st. Y to the 4th, that can stay because it's even. And z to the 5th, we're going to break that down into z to the 4th, z to the 1st power. And with these odd ones, I'm just breaking them down into a variable to the 1st power, and then one less than whatever variable it was. Or I'm sorry, whatever exponent it was. All right, then let's go through and do the perfect squares. Square root of 9, that's 3. Square root of 8, well actually that could be broken down a little bit further, but we'll do that in a second. So that's not a perfect square, we'll leave it square root of 8. Square root of x squared is x. Let's see, x to the 1st power, we've got to keep that as square root of x. Square root of y to the 4th is going to be y squared. Square root of z to the 4th is z squared. And z to the 1st, it's an odd exponent, so we have to leave it as square root of z. Okay, so let's go through and let's grab everything that does not have a square root. So 3x, y squared, z squared. That's going to come out front. 3x, y squared, z squared. And then everything else that has a square root needs to stay under the square root. So we've got 8xz. Now, taking a look at that square root of 8, we can actually break that down into a number that is a perfect square. We know that, well, let me copy this down again. we know that square root of 8 can be factored down into 4 times 2xz. That stays. And we know the square root of 4 is 2. So we can bring a 2 out front. So we're going to have 3 times 2, which is going to give us 6. And then we have all of our variables, x, y squared, z squared, square root. We just did our square root of 4, so now we're left with 2xz underneath the square root. So here is our most simplified answer. All right, lastly, example number 3. We have square root of 11y, square root of 11y divided by square root of 27. Okay, this looks very similar to stuff we did yesterday, but we've got a variable. And as we're taking a look at it, our first instinct, like yesterday, is going to be to multiply by the square root of 27. And multiply by the square root of 27. And we can go ahead and do that, but it's going to give us a really big number in our numerator, and it's going to make it kind of tough to figure out if there are perfect squares. So here's what I want to do instead. Is square root of 27. Let's actually break this down into perfect squares first. Square root of 27, we know that that can be broken down into square root of 9 times 3. And we know that the square root of 9 is 3. So we can have square root of 11y over 3 times the square root of 3. And this would just be perfect if it was perfect squares, but it's not. We do have a square root in the bottom, and remember, we can't have radical signs in our denominator. So we actually need to keep going. So if I take my square root of 11y over 3 times the square root of 3, we only need to multiply the denominator by what's in the square root. So we're going to multiply by the denominator by square root of 3 and our numerator by square root of 3. Okay? And the numerator is going to give us square root of 33y over, this is kind of cool. We have this 3 out front, okay? And then square root of 3 times square root of 3, remember that gives us the whole number 3. So we're going to multiply by 3 in our denominator. 3 times 3 is 9. So our final answer is going to be square root of 33y divided by 9. There is our final answer. All right, so today we are working with variables and square roots. Whoops, here we go, next one. So we're ready for our summary. Write down what you learned, what you need to remember on your notes, on your summary sheet, or in a foldable study guide. This is Ms. Johnson. Thanks for tuning in. Day 2 of Simplifying with Radicals.